Bismillahirrahmanirrahim. Assalamu alaikum, students. The today's session, this is in continuation to the previous lecture I delivered about relational algebra. Some of the aspects related to relational algebra regarding its operators, we have discussed in that. And now we have to discuss the other operators, the rest of operators, those we were unable to cover at that moment. So the today's lecture's objectives are that we have to learn basic and derived operations in relational algebra. And we have to start with the Cartesian product, which is the binary operation. And it is very, very important topic. So we have to do Cartesian product for the relations from which we likely to get the information that's not available in a single relation. So we have to combine two relations. For that, the Cartesian products is one of the operation that we have to carry out at the outset. So how the Cartesian product is to be carried out, and further how this Cartesian products are used with the join operations. The join operation we have to discuss, because if you need information data from more than one table that's not available in a single table, then we have to combine those, and we say that we are joining the tables. We also discuss the different types of joins and further divide. These operations are derived operations. Further, we have to discuss the division operation also. So prior to discussing the topics, I just give you what we have already learned. We covered the topics within the last lecture, those related to relational algebra and relational calculus. I told you that relational algebra and relational calculus, it is the fundamental, and this is theoretical languages on which structural query language is based. So learning relational algebra is very important for the students who have taken databases as a course. So in that we studied different operators, which we call that these are unary operators and binary operators. So within the unary operators, we discuss this selection, that is also called restriction. We discuss the projection and renaming, and these operators are applied on a single relation, so these are called the unary operators. For the selection, you have to say the select operator filters the rows according to the given condition from a relation. On the next slide, if we go for the projection, when we use that project operator, we likely to get the attributes, those are needed attributes in our resultant relation. And the attributes, those are not needed, we have to discard them. Further, we also discuss the renaming, in which we can rename any attribute. So these are operated on a single relation, so called unary operators. In addition to, we also discussed the set operators, that was union, that was binary operator, because what it does, it gets the information from two tables, and we say that the tuples have some sort of from one relation, and tuples from the second relation, we get the union of that. So all the tuples from the both relations are included. Next, we discuss the intersection operator. We have already discussed with you that when you use intersection operator, your purpose is that you have to get the instances or the rows. Those are common with the relations for which you are applying this intersection. This is the same as you are doing intersection in the set theory. Might be you have already learned in your earlier classes. When there is a set A and set B and you likely to get the intersection of set A and set B, then you say the common element should be retained. Similarly, it is that. So we also discuss the difference operator, and within the difference operator we say that two relations that R and S, we have to calculate R minus S or S minus R. And I told you that the R minus S never equal to S minus R. So in today's session, we have to start with the Cartesian product. So if you think about the mathematics that you may have learned, this Cartesian product or cross product in the set theory. So for example, that you have a set 1, that is D1. Its values are 2, 4. Two elements are there. And for the set D2, the 3 elements are there. Now, if we have to carry out the Cartesian product for these two sets, what we have to do? We have to make some sort of order pairs, taking an element from the D1 and the other element from the D2. And then we have a set of ordered pairs that as a resultant, we say this is the Cartesian product of D1 and D2. So in this example, we take the first element 2 and we have to relate with other elements of the D2 to make pairs. So we say 2, 1, 2, 3, 2, 5, and further you have to take the other element to 4 and have some sort of carried out this product in a way that pairs should be made 4, 1, 4, 3, and 4, 5. So in this matter, this 2, 1, 2, 3, 2, 5, 4, 1, 4, 3, and 4, 5, the set of pairs we got after D1 cross D2. So further we say that if I take any subset of this set of that is of ordered pairs, again that is a set. So in that manner we can say if we get the cross product of two relations, let's suppose R1 and R2, that at the end we get an other relation R. So whenever you have a cross product of two relations, the resultant of the two relations for which we have to carry out Cartesian product, basically that is also a relation. So it should be clear from this example, we have taken one relation named as R and other relation named as S. So we have to find R cross S. So with the R cross S, we get all set of concatenated tuples. Yeah, that is basically XY. So one thing to remember that if we have one relation R, it has two attributes A and B, whereas S relation has two attributes C and D. So when we carried out Cartesian product, the resultant table must have attributes that is the sum of the two attributes, that is A, B, C, and D. There should be 4 attributes because 2 attributes from relation S and 2 attributes from relation R, that we say A, B, C, D, 4 attributes. Further, we have to say this is columns in R plus columns in S. That should be the total number of columns in the resultant table. With the cross product, the other thing that we have to remember that the number of rows in the resultant table are the number of rows those are in R table multiplied by number of rows in the S table. So in that manner, you can see there are 2 rows in the R table and 2 rows in the S table. So 2 into 2, 4. So in the resultant table, we will get 4 rows. So similarly, how it should be carried out, you have to take the first row from our table, that is x1 and x2. Now relate it with the 2 rows of the S table. So we may say x1, x2, y1, y2. Then we say x1, x2, y3, y4. Now again, take the second row from the R table and relate it with the 2 rows of the S table. Then we can say x3, x4, y1, y2, x3, x4, y3, y4. So this is the resultant table. So you have to keep in your mind whenever we have a cross product of two relations, then the resultant relations had number of columns. How much? Number of columns of relation 1 plus number of columns of relation 2. Further, if you say how many rows should be in the resultant table, then you can say the rows of relation 1 multiplied by rows of relation 2. So this should be the output of the resultant table. So what I told you that let R1 and R2 are two relations with m and n tuples. So we have said the R1 has m tuples and R2 has n tuples. Then the resultant table after cross product of R1 and R2, we have number of tuples m multiplied by n. On the other hand, if we say that a number of columns of R1 is let m and number of columns of relation R2 are n, then how many number of columns should be of the resultant table? That should be m plus n. So this should be remembered on your part when we have to do Cartesian product. Further, we are doing Cartesian product in the two tables, and this is a binary operator. Now get this example. I have considered two tables. One table is student and other table is student grade. Within the student, we have two columns, name and roll number. And within the student grade, we have two columns, that is RNO and grade. So in first table, two attributes, in the second table, two attributes. So we may say within the resultant table, after cross product of the student and student grade, we will get 4 columns. Regarding the rows, that there are 2 rows in the student table and there are 2 rows in the student grade table. So we have discussed the total number of rows in the resultant table should be m multiplied by n. So that is 2 multiplied by 2. So this is the 4 rows that have been generated after cross product of student and student grade. So we have to think that after cross product, we got 4 rows. These 4 rows are meaningful or not. So think about if I say, what is the grade of Sajid? So from the first table, you say Sajid roll number is 101, and from the student grade, that a person who have roll number 101, his grade is A. You can say the Sajid has gained grade A. Now go to the resultant table that we got after product. From the first row, we had say the Sajid, roll number 101, RN 101, its grade is A. So this is okay. And again, there's another row in which say the Sajid, roll number 101, and again this roll number 102, and grade is C. So this is surplus tuple. It's not matching our first two tables in which we can get the information that Sajid has grade A. So this is superfluous, this unnecessary has been created. Similarly, go for the next, for the Bashir, you can say its grade is C. So from the resultant table, you can say Bashir, roll number 102, yeah, has grade A. So his grade is not A, but his grade is C. So the last row say that sure that the Bashir has grade C. So in that manner, you can say these two rows, as I have highlighted in yellow color, those are surplus tuples. Those are unnecessarily generated, and we are not concerned with that. So if we think about how we can get rid of such surplus tuples, it is only possible that you have to filter the tuples. In order to filter the tuples, we have an operator that is called selection. We say this is the sigma, and we must give the condition that the roll number of the student relation must be equal to Rn of the student grade relation. And we have to take all these rows from the table, that is cross product of student and student grade. So in that manner, you can avoid these rows. So you have seen that with the Cartesian product, some surplus tuples are generated, and in order to avoid that, we have a sigma operation, that is selection. Yeah, so it may address this surplus tuples. So take this example. It is one of the relation, that is employee, and other relation is jobs. So within the first relation, we have 3 attributes, and within the second relation, we have 2 attributes. So surely with the resultant table that we get after cross product of employee and job, there should be 5 attributes. So the 3 attributes from the first relation and 2 attributes from the second. This m plus n we have already discussed with you. Further, there are 3 rows in the employee table and 3 rows in the jobs table. So surely we will get 9 rows. So within the resultant table, we have 9 rows. So if we consider the same thing, whether the person whose employed ID is 101, his employee job ID basically is equal to CK. So whether what is his job, so you can say from here the 2 table that the another designation is clerk. So can you get it from the resultant table or see the resultant table? Because for this first row, that's 101 another and CK, we have related with the 3 rows of the jobs. In that manner, we have created 3 rows. One is 101 another CK, and then you say this is CK and clerk. Yeah. The further we have to say 101 another CK, CDR and coder, and third one is 101 another CK and TST and tester. So these first rows was related with the 3 rows of the job. So 3 rows created. Take the second row 202 Bashir and CDR. Again with the 3 rows, those are available in the job. We will again create 3 rows. For the third row in the employee table, again these are related with the other 3 rows of the job. Again we get 3 rows. So we at the end in the resultant table, we got 9 rows. So the first row is okay, but in the second row we say the Nazir is coder, where Nazir is not coder. So this is surplus. Then this is Nazir, this is also the tester, where he is not tester, he is clerk. So this is also a surplus. So similarly, I have indicated in red color those rows, those give you what is reflected in the employee and job table. So the other rows created, those are surplus rows, and those are not meaningful in that manner. So how we have to avoid that? Again, you have to go for the selection process, that with a sigma, that the employee job ID must be equal to the job's job ID. So if we do that in that manner, we can address these surplus rows, and then these surplus rows with this selection process should be discarded. So at the end we can get the 3 rows, 101 Nazar, that is CK cleric, and 202 Bashir CTR coder, and 301 this is Shajar TST tester. So just you have to remember, when a Cartesian product is carried out, that it will generate some surplus rows, additional rows you can say. And how we have to avoid that when we have to do Cartesian product? We have to go for our operator, that was selection operator, in which we have to filter the rows. So we have to filter the rows according to some condition, and within that we say that the condition is that the attribute in one relation, that R1, and attribute in the second relation, that R2, that should be equal. Now we have to discuss the join operations, and you can raise a question when we are going for the join operation, why you say Cartesian product is must and we have to carry it out. So for all the join operation, the first operation that we have to carry it out, that is basically the Cartesian product, because we like you to join two relations, let's suppose R1 and R2, and then you can say the join operation is binary. And whenever we have to join two relations, then at the end the resultant we get another relation as a result. So join is a binary operation, and it combines two relations R and S, and the new relation give the new relation. And join operation is a derived operation. So furthermore, it allows independent tables linked by a common attribute. So you have to remember, whenever you join two tables, so there exists an attribute within the both, that is the common attribute. So this is the second condition for joining. So join is a derivative of Cartesian product. We like you to carry out Cartesian product before joining the tables, and further perform the selection operation. Why we do the selection operation? When we do carry out Cartesian product, surplus rows are generated. So we have to discard those, and then we have to filter the rows with the help of the select operator. Join operation is denoted by this bow tie. So we can say that general form of join is R join with S, and there should be some join condition. For you say that if the join condition is the two common attributes should be equal, then we can give it here. For the join condition, we have to specify. Within join operations, we will study the natural join, and symbol is given, and theta join. Again, it is appended with the symbol theta. And we have EQ join, in which the condition is that the two attributes value should be equal. The further operations are outer join, And for the outer join, we have left outer join, right outer join, full outer join. So I have to discuss each of these one by one. Join operations with natural join, theta join, EQ join are called inner joins, because in the previous slide you have said we have outer joins, yeah, and we say the natural join, theta join, equal join are inner joins. Within these inner joins, the resultant table, it may include all the rows with the matching attributes, and in which the value of one attribute that is common with the second attribute of the second relation, that is which is common between the two, and we say whether the values of those attributes are matching or not. So for the tuples for which there are matching values, we have to retain those tuples, and where we have to discard the others. With the theta join, we use another operators. Those we have discussed in your programming language, relation operator, that is like greater than, less equal, greater equal, not equal, etc. We can use these operators with our condition. So that is theta join. We will discuss in next slides. In EQ join, it is also a kind of theta join, but the operator that is used in the condition is equality operator. So natural join is an equijoin on attributes that have the same name. Although the natural join not explicitly mention that condition, but implicitly it is there that the common attributes must have the same value, and the names of the attribute that is common with the two relations, that R1 and R2, that should be the same. We now go through examples and get the concept. So this is the overall for the natural join. Let's suppose you have a R table in which we have two attributes, and with the S table we have two attributes, and the second attribute in the first table, that values are B1, B1, B2, and the first attribute of the second table. This is basically the common between the two tables. So what we have to say? We have in the very beginning go for Cartesian product, and for the Cartesian product, then we have to go for what the rows we have to select in which the attribute of common attribute that is within the two tables, their value should match, and then we have to filter that. And one thing that I have seen at the resultant table, that with the Cartesian product there should appear four uh, attributes, but here are three attributes. It means the natural join discard the common attributes, it keep only one copy. And if you say these are the three rows, and in the second table three rows, there must be 9 rows in the product, cross product, but we have retained the rows in which the value of attribute for the common columns are equal. The b1 is equal, and we say again this b1 equal, so b2 is also equal within two. So it should be clear in the next operation that I will carry the example for you. So natural join tables by selecting only the rows with common values in their common attributes. Just we have to take it, but the step that should be carried out in order to carry out natural join. First step is that carry out the Cartesian product of the tables those are considered for the join. The second is we have to go for selection, and select operator we used, and in that manner we will get only rows for which the values of the common attributes are equal, and in which the values of common attributes not equal, those rows are discarded. So the select may help to filter the rows. And the third one, because we say the natural join, it only keep one copy of the attributes that is common between the two relations those are taking part in natural join. So we have to go for projection. So the general form is that we have to, our natural join S is equal to, we have to, in the very beginning, we have Cartesian product, R and S. Then we have to get the filtered record where we have to give the condition for join. And at the end, we have to get the number of attributes, and only attributes that have common name. Yeah, in both we will keep one copy of those. So consider this customer table and supplier table. In the very beginning, we have to carry out all the three operations. The operation one is that we have to calculate the Cartesian product. Operation two, we go for the selection, filter the records. And third, we have the projection. And the three operations should be carried out on these two relations, customer and supplier. And I will explain each and every step one by one. So for the Cartesian product, what we have to say that you have to got the first row from the customer and relate it with three rows of the supplier, S01, S02, S03 rows here. So the first row should be related with the three rows, it will generate three rows. The second row also related with the three rows. Again, this operation also create three rows. Then there are six rows. And when the third, we have to relate with the first row, second row, and third row. So we, at the end, we will get 9 rows. So the first row should be 101 Asad, Faisalabad, 10 S01, S01, and double two triple three four five. The second row should be 101 Asad, Faisal, S01, then go for S02 and triple three eight nine seven six. And again 101 Asad, Faisalabad, S01, it relate with the third row, S03 and 453. So in this manner, three rows should be generated. Now take the second row from the customer table, this 204 Nasser, Rawalpindi, S09, and related with each of the row in the supplier. The first row, the S01, double two, triple T, 4, 5. This should be one row. The second row should be 204 Nasser, Rawalpindi, S09, S02, and this one. And third row should be 204 Nasser, Rawalpindi, S09, and S03, and 4530912. That we have to see in the next slide. So these are the 9 rows related, and the number of columns in the relations, that is 4 columns in the customer relation and 2 columns in the supplier relation. So we will get 7 columns in the resultant table. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this is within the 2 tables. We have 6 columns. There's 1, 2, 3, 4, 5, 6. So 4 columns from here and 2 columns from here, and the resultant table would have 6 columns, not 7. So in the very beginning, we have carried out the cross product of customer and supplier, and we get these 9 rows with the 6 columns. And the second step is that we have to use select operator in order to pick the rows in which the common attribute, that is supplier code from the customer and supplier code from the supplier, those are equal values, and other we have to discard. Now see, and I have this 101 Asad Faisalabad S01 S01. The supply code of the supplier customer and supply code of the supplier are same, so I have retained it. You go for the second row, and here the supplier code is S01 and supplier code of the supplier table is S02. So these are different, so I have discarded it. Similarly, I only retained those rows in which the value of common attribute, they have the same value from the two tables. Those are taking part in natural join. So we will get the result. We have discarded only these tables that I crossed the rows in which the supplier code of customer table not equal to supplier code of the supplier table. So when they are different, not matching, so unmatched, these rows has been discarded. So this is done with the help of the step 2, in which we have to carry out our selection process. Now we have to go for the third step. In the third step, what we have to carry it out, we say that the common attribute that is within the two tables, it should appear once. So we have to keep the one copy of the attributes that's common. So the common attributes with the two tables, that was the supplier code. See, this is the supplier code within the customer table and supplier code with the supplier table. The supplier code is the common attribute. So the third step is we have to retain one copy of this one. So if we go for the projection, and for the projection we got customer code, customer name, customer address, and supply code, whereas it occurs twice in our Cartesian product, but now we have get one copy of that. So you can say the resultant table of natural join of two tables, that was customer and supplier, that is giving two rows and giving 5 columns. What is the notation for that? You have to notation this customer natural join supplier equal. We have to say this is the relation for which we have to have our cross product, customer and supplier, and the join condition. In order to filter the record, we use this sigma operator, the selection, then the projection operator. So the natural join of two relation returns all the attributes of both relation, but keep one copy of the common attribute is returned. So these are the three steps that we have to carry out in order to have natural join of two tables. This is another example, and you see this is one of the table is employee, and second table is department, let's suppose. And you have seen there is a common attribute within the two tables, debt ID and debt ID. So we have to be able to go for the natural join, and within the first table we have 4 attributes. Within the second table we have 2 attributes. So the resultant relational table must have 6 attributes in the cross product. So these are the cross product of two tables. There are 3 rows, and here the department has 2 rows. So in that manner, after the cross product, we will get 6 rows. So 6 rows are there. The same operation you say to get the first row of the employee table and relate with 2 rows of the department table. We have done that, and this is your step 1. Then we go for the step 2. For the step 2, we have to filter the records, and we say we have to keep only those records in which the value of the common attribute is same, they are matching, and we have to discard other rows. So in the first record, in the first row, we have 101's Sajid pay 25,000, and department of the department and the employee the same D1 and D1, we have kept it. And similarly, other 2 rows, 201 Basit, in which the department ID of the both relation taking part in join, they have D22, we have retained it. Similarly for the third. And other three rows in which there is no matching, the department ID of the employee and department ID of the department that is not equal, we have discarded those. So this is the second step we have carried out. And the third step, you say that we have to go for the projection. Only what we have to do, we have to keep the copy of the attribute that's common with the relations taking part in natural join. So department ID was common, so we have kept the one copy of department ID as an attribute. There's no need to write it twice because this is the same values. So we have discarded one copy and kept one copy of the attribute that's common. So we get the end result of this natural join. We have to get 3 rows and with 5 columns. So this is the basic concept of your natural join. This is another example for the natural join. We have a customer and rep, and we have carried out its cross product, and then we have to carry out the selection process, and then we have projection process operation and get the result. So you have to do it on your side. I have given the results of this one. Then you say do the exercise and get whether your result table is the same as I have calculated. So it should be the resultant table after natural join, in which the attribute that was common, that was we kept one copy of that, and there are 3 columns in the customer and 3 columns in the rep, and the rep number column is common between the two relations, customer and rep, so it should be written only once. And furthermore, we have to discard the rows in which the rep number of the rep table and rep number of the customer table are not equal. So you have to see that only the 2 rows were there. Page up. Here we have say this is 701 Peters 05. Its rep number is 05, but there's no rep number here 05. There's no matching. So the row that's created with the help of this one should be discarded. Furthermore, we have this also, the 75, that is not available here. So we have to discard also this one. The other rows should be kept because they are matching the common attributes values. So the next join operation that we have to go for, that is eq join. I just only say that the eq join is almost the same as the natural join, but a little difference between two. Here we have say the 2 columns, those have same values. We have to retain those rows. But one thing is that in eq join, it's not necessary that the columns name should be the same. So all other operations should be carried out in the same way, that we have go for the Cartesian product, then we have go for the selection. In selection, we use the condition that the value of the attribute from one relation equal to value of the attribute of the second relation, and these are those attributes, those are considered as for equijoin. So equijoin, you say, that's also links on the basis of equality condition that compares the values of the columns. Those are considered in each table. Condition must define explicitly. Whereas in the natural join, we haven't defined explicitly that the value of the common attributes should be the same. That is considered implicitly. In equijoin, we have to define it explicitly. So equality condition specified on two attributes require the values to be identical in every tuple of the result, because we have to retain only those uh, tuples in which the value of the attributes are identical. So it is a special case of theta join, because the theta join we also use other conditions with the help of the less than, greater than, less equal, greater equal, so and so. But in this we have uh, to specify the condition with the equality sign, that the two attributes, those are considered for the equijoin, they must be value of those should be identical. The columns name do not need to be the same. The one thing that differ it from the natural join, in the natural join the names of the column should be the same. So further, the second thing, the outcome of the equation does not eliminate duplicate columns. So we say that at the end we get the result in which the duplicate columns are not discarded. So we are doing your Cartesian product and the selection process. This is the same table. So for the same table, we have to say we have to keep the records or the tuples in which the supplier code of the customer table equal to supplier code of the supplier table. So in that manner, we will get might be two rows. In the first row, 101 supplier code of the customer table equal to supplier code of the supplier table. And in the third row, you have observed that there is S03 and S03. So this also matches. So at the resultant table of the equijoin, we may get two rows. So these two rows are at the resultant. And what we have seen that customer code, customer name, customer address, and supply code of the customer table and supply code of the supplier table, those are there. So this duplication is there, whereas this duplication has been discarded in your natural join. Furthermore, the condition that this customer.supplier code equal to supplier.supplier code. So the attributes that we are equating, that the supplier code. So that is explicitly defined in the equijoin. And this is, we have to denote it R equijoin. Yeah, this is the condition given with the R table. Yeah, and this table is basically the resultant table that we got of the cross product. So now we have to go for the outer join, and within the outer join we have also discussed the other types, the left outer join, right outer join, and the full outer join. So the definition of the outer join is that whenever we have to join two tables, the matched pair would be retained. That we are doing within your natural join also. So matched pair would be retained, and any unmatched value in the other table would be left null. It means not only the values in which we match the pairs according to our attribute, that we also retain the rows in which there are unmatched values. For the unmatched value, when we detail that row, the unmatched value should be left as null. They should be considered as null. So in the outer join, unmatched records are also included, not only the matched record. And but the unmatched record, that the values from the table that is not having that matching, that should be considered as null. So for those records that do not data common in both tables, we say for that value is considered to be null. The outer join returns all the matched records that are in the inner join returns, because in the inner join we also say we retain the all the rows they are matching the criteria. Plus it returns the unmatched records from one of the tables. So it also retains the unmatched. So it should be clear from the next example. Let's suppose that we have this table, customer table and rep table. Yeah, and we say we in the previous slide we have seen that the two rows that 701 Peters 05, it have no matching with this one. Yeah, 05 is not within this rep numbers. The rep numbers of rep table are 20, 35, 65 and 75. There's no 05, so it is unmatching. Further from this table, if we say that the 75 Lears and John, it's not matched with any of the rows within this customer table. So these two rows, those are unmatched, and that we have to go for the next slide. So these two we have retained in which the rep number was same. These rows are matching criteria, where these two rows are unmatched. So we have this value 701 Peter and 05 available in the customer table, but this value is not available from the other table. So we have put it as a null. So see it again. We have this 701 Peter 05 in the customer table, but no matching with this one. So if there's no matching for this one, so the values for this one should be null. So similarly for this one, for this record 75 Lewis and John, you have seen there is no matching criteria with the customer table. So these values are kept as null. So this is the outer join. So within this outer join, you have seen that what we have to do, we have to do the cross product. Then after that, we have to see how the rows should be retained. We say like inner join, we have retained all values. Those have the values within your attribute. Those are the same, the matched values. But we in that joints, inner joints, we discarded those rows in which there is unmatched. But within the outer join, we have kept those rows, although those are unmatched, but with the null values. So this is the difference between the two. So the outer join may be left outer join, right outer join, and full outer join. So I have to discuss each of them one by one. But remember the concept of outer join. Now we have to consider these two tables. Those were customer and supplier. Those are already available in our slides. And we have to say that we likely to go for left outer join, right outer join, and the full outer join. So what we discuss in the outer join, what we say that we have to keep all the rows, those have the matching values, and also retain the rows in which values are not matched, but with the null values. We add those. So it is the outer join. All the tuples of left table is displayed. Its definition reflect that all the rows from the left table should be retained in the very first, irrespective they are matching or not matching, from the left table. And from the right, what we have to do, in the right table, only those are present that satisfy the matching condition. So from the pictorial notation, you have say this is the table A, let's suppose this is table B, and all the values of the table A have been retained. but we have to retain the values from the table B that is basically having a matching. But with the outer join, we also say that we also retain the unmatched records. So it should be clear from the example. So in the very beginning, we say this is our, keep in mind that we have customer code, customer name, customer address, and supplier code. These are the three rows: 101, 204, 305. So we have to retain the left table. So this table should be retained. In the very beginning, we have to say in the resultant that this three rows should be retained. Yeah. So these three rows have been retained. This is customer code, customer name, this customer address, and supply code. From the these three rows are retained from the left table. And she say that from the right table we have to retain with the matching conditions, and for the non-matching we have to include the null. So we have said that this which are matching and which are not matching. Take the Here we have seen, and here the supply code and supply code are matching, and the supplier code and supplier code are matching, but this S0 is not matching with this one. Yeah. So for this phone number, we have to say it is null. Yeah. And we have to say for which it should be the null value. Here we say this is matching. S01 was matched, S03 was matched, but S09 was not matched. So in that manner, we have included the null. So what we have done, we have retained in the resultant table all rows, those are matching, but also those rows, those are not matching, but with values null. So it is the customer, left outer join, and supplier. What is the difference between the symbol that these two lines are extended, or you may say appended on the left side? If this is on the left side, then you say this is left outer join. If these two lines are here appended either on right side, then you say this is the right outer join. And if these symbols are that these extended lines are on both sides, then we say this is full outer join. So hoping this should be clear. With the left outer join, you have to retain the table on the left as it is, yeah, whether it's met the condition or not. But on the right table, we have say that we have to retain the records, those matches, and also we retain the rows in which there is unmatched of the attributes values, and but we have to include null for that. So we have to go for the right outer join. For the right outer join, you have seen from the factorial notation that all the values from the table that is on the right hand side that should be kept, irrespective they are matching the condition or not for the attributes given. That what we say okay, we have to consider the attributes for the condition, the values either match or not match. We have to keep the table on the right side as it is. But from the left side, we have said that we have to keep that as matching, but unmatched records that with values of the null. So for the two relation that we have already considered, we say what should be the result. And here we say that the supplier code and the supplier phone, these were the attributes that from original table, we have said the supplier table have two attributes, supplier code and supplier phone. With the right outer join, we have to keep this table as it is. So for this table, we need three rows, S01, S02, S03 with these phone numbers. These should be retained. And from the left, we retain that matching code, and which is not matching code for those we have to add the values as null. So see in your resultant table. So this is a right outer join. We have kept these 3 rows from the right table, the supplier code and supplier phone. These are as it is. So S01 and S03 were matched, so their rows are here. But this S02, yeah, and on the other side there was another value, that is S09. This S02 and this was S09. This was not matching. So in that manner, what we have to do, we have to add values null for that. So for the S02, we have added values null. So in that manner, we have retained the rows, those match the condition, match the supply code values, and those are not matching. We also consider those, we also retain those, but the values of the null. So this is right outer join. So we have to go for the next, that is full outer join. And for the full outer join, we have to say the tuples from both relation take part irrespective of whether it has the matching or non-matching conditions. So you can say if you get the result from the left outer join, right outer join, and if we have for the full outer join, we have to get the rows, those are matching values, and we also have the rows from 2 tables, those are unmatched. But the values, those are unmatched, for which we have to add it null. So what we consider that these 2 values S01 and S03 were matched, yeah, and this was not matching in the right, and this was not matching in the right and left that we have already considered. So see that in the previous slides. So in the right outer join, these were missed, yeah, not matching. And for the left outer join, this one missing S09. For that, this is null. So these should be included in the full outer join, and we get the result in this manner. So these null values, those are unmatched here, yeah, and S09 and null are. So this should be the full outer join example. So we have considered the outer join, that is left outer join, right outer join, full outer join, and in the very beginning we considered what is outer join. Just we have to say we have to retain the values that has the criteria, and we have also retained the values that are not matching the criteria. Whereas in the equijoin and with the natural join, those are inner joins, we say that we have to keep the values, those are matching criteria. So these are also examples. This is a country and the state in which this source is from the internet. So we have created this table, yeah, and do this example by yourself and try to get the result and see whether your left join you get it's good, because from the left join we have to this table should be kept as it is, yeah, and from this table we have to keep the values, those are matching, but we will also get the values those are not matching, but we use the null. So for this is 2 attributes, these two attributes are here, and these we got all these rows, yeah, and from here we also rows, those are matching the condition, but in addition to the row that is unmatched, so this is null null null. So try that for the left outer join, also for the right outer join, and also for the full outer join. So in this manner you have to do practice for it, and then we'll get the concept of this one. So this is right outer join with the right outer join, but you have to keep the table that is on the right side. On the right side we have 3 columns, 1, 2, 3, and this all table should be kept within the right outer join. So for the right outer join we have kept all these values, and from the left those are matching, and that's not matching, we have included the null with it. So this is right outer join. For the full outer join, we have said that unmatched values for rows for unmatching, non-matching condition, those are included, and also all the rows those have matching conditions, those are also included. So tuples from both relations takes part irrespective of whether it has the matching or non-matching relations. So these are they were non-matching that we have included, and this was also non-matching, we have also included. So this is called full outer join. Yeah. So now we have to consider the theta join. With the theta join, we have some sort of input relation, and only those selected rows are used in cross product to be merged and included in the output. So what we have to do in the very beginning, we have to apply condition on the relation, those are input relations. And after applying the conditions, that is one attribute is greater than or less than or are not equal so and so with the other attributes. In the very beginning we have to apply this condition, then after that we have to go for the cross product, whereas earlier we are doing the cross product and then we are doing our further operations. So it means that the normal cross product, all the rows of one relation are mapped merged with all the rows of second relation, but here only selected rows of relations are made cross product with the second relation. This is the only difference with the theta join. If you say there are two relations R and S, and we likely say that we have to go for theta join for R and S. So applying that in the very beginning, we have to apply the condition, and we have to get the rows. Those are only matching the condition. Those we have to retain those in the both table. Then we have to apply our cross product. So theta join which are not equijoins are called non-equijoins. The join condition is denoted by theta. So we have to go for the let's suppose we have a theta join for the mobile and laptop, but the condition is the mobile price should be less than the laptop price. So in the very beginning this condition is applied, then after that the cross product is applied. So the mobile price is less than laptop price. The laptop prices are given here, yeah, and the mobile prices are given here. So in the very beginning we have to apply this condition. We have to take the rows in which the mobile price is less than laptop price. Here the mobile price is 10K, and this mobile price should be less than the laptop price. So we have to relate this row with other rows of the laptop in which the price of the mobile is less than price of the laptop. You have say I have to relate with the first row. Asus 10K is 20K because the price of the mobile is 10K and the laptop price is 20K, or 10K is less than the 20K. So I have to relate it with this one. Now for the second, we have to go for Asus 10K, that's HP, and 35K. Again, the 35K is greater than the price of the mobile because it's 10K. So I have to relate it with this one and retain this one. Third, we have to say Asus 10K, and we have to relate with the Apple because the Apple price is greater than the 10K. So we have three rows in this manner. Asus 10K is 20K, Asus 10K, HP 35K, Asus 10K, and Apple. So we have to get these three rows. Now go for the second. Here, this is the value of the mobile price is 20K. So I have to relate it this one. I can't relate it with this one because here the Acer's price is also 20K. The 20k is equal to 20k, but not less than that. So this should be discarded. I have not taken that. So 20k is less than 35k. So this row should be, and the 20k is less than 80k. So these should be available in the cross product. Now we have to go for this one. Applying the condition, we say this is 50k and 50k not less than 20k, not less than 50k. So these should not be related with these rows, but in cross product, 50k should be related with the 80k because 80k is greater than this one. So in that manner, we will get the resultant table. And this is ASUS is 20k, 35k, Samsung for 2, and this. So this should be the cross product. But this cross product is after applying the condition, because we have 1, 2, 3, 4, 5, 6 rows. And if we go for the original tables, then we say this is 3 rows and this is also 3 rows. The rows in the cross product should be 9. Why it is not 9? Because we have applied the conditions given prior to cross product. That is one of the prerequisites of the theta join. So when we say that by both mobile and laptop side, that if you likely to got this one, so we can say this is the Cartesian product of that, and it is we get after applying the condition, and at the end we can say that this should be the laptop and mobile that we can purchase. This is the combination of those. Yeah, so buying mobile and laptop applicable are this one. So this is one of the example of the theta join. We can use even the same example with greater than, less than, not equal, etc. And then you have to do the practice for that. The last is the division operation. It is denoted by the division symbol. So in which we have two relations R and S. With R relation is attributes A1 up to AN and B1 up to BN. But for the S, that's dividing the S, and this one of the common attribute is there. So it should be more clear from the example. And the division operation is useful in special kinds of the queries in which we include the phrases for all. We have to calculate something for all, and that is applicable there. And we will practice it when we will discuss the statements of the SQL with you, and how these all operations are carried out, and how these have been implemented with the structured query language. So with the example, it should be more clear. Let's suppose that R column, let's suppose R relation has two columns, A and B, and S relation has only B column. That's the common column within the two. Yeah. And here we have to see that how many transactions in this table on the left side, those have A, B, C. Yeah, they contain these A, B, C values. Yeah. So in the first we have AB value, in the second we have ABC, in the third we have ABC, and in the fourth we have BC. So in that manner, you can say that ABC and ABC are available with the second and third, this one, these transactions. So we can say that if we divide this R divided by S, so this should be the resultant. So get another example that we have say. Let's suppose this is a table. This is let R table. It has code and location, and it's divided by another, that is the code. So here the code in both relations are common. So what we have to do, we have to look for whether the values A, B are available in any of these values of the code, but this code that is in this table must have the two values A and B. So in the very beginning we say the code A and code A, this location is 5, and we have to see whether the code B also have location 5. Here we see the code B is also location 5. So one record should be this one, that the location should be 5. Okay, because we have to pick out the location. For second, we have to say for B, we have said that AB is available, B5, B3. No, AB is available within other C or D code. No, there's not available. Only one A is available code. Yeah, A, this one A5 and B5. So for the location 5 and this one 5, yeah, these AB are locatable within this 5, this 5, this 5, this is the same. So at the end we say the location is 5. So this is the division process. Table 1 is divided by the table 2 to produce table 3, and we contain the code column but not the share the location. So to be included in the result table, values in the unshared column log must be associated with every value in the table 2. So these values should be associated with each. So get this one. Further, we have to go next example. Let's suppose this is another table. This is order line and part. We have to see whether these part numbers, this one, those are associated with any of the order number. So if we go for looking at the DR93, the DR93 is here. This is 21610, and DW11, DW11 is 2610. So these two values are associated with 21610. So the order number we get with this division, we say the part outer line divided by part, we get 21610, and none of the others are. So the resultant of the new table reflects that those order numbers that match all the part number appearing in the part table in order line transactions. Yeah. So this is the division. Yeah. And this is another example from K8. Say this is the student, this is language having 1, 2, 3, 4. This is records, and this is divided by this one. So what we have to say, whether this English and Hindi, is it available for the any student who is taking this language? Yeah, and we say this is English and Hindi. This is English, Richi, and other. Say the Hindi is Richi, Hindi Richi. Yeah, the English, this is Ruchi, and Hindi also Ruchi. So we have to keep it. So we see if the student table is divided by this the language table, then we get resultant. So this is the division operator that we may apply on two relations, and this is also a binary relation. And so this was all that. This is the second part of our relational algebra, in which we have discussed the Cartesian product and the importance of the Cartesian product. And furthermore, we discussed the different operators, in which we have join operators. So we have natural join, equijoin, theta join. Then we have said outer join, and we say this is left outer join, right outer join, the full outer join, and we also say we call that the natural join, and those are the equijoin, etc., the inner join. And within the examples, we also there is a big difference between these join operations, and these join operations are carried out on two relations, that is the binary. And we also discussed the division, that is also binary, in which two relations are involved. So from the examples that you got some concept, and try to solve these examples at your part, and take another examples, so you will get the concept of that. So this is the from my side. I have recorded this lecture and I will send you now. Okay, thank you so much.